All right. Good evening, everyone. We're in topic 10, block 3. We're representing and interpreting data. Today's goals and objectives are going to be to use data from a random sample to make inferences about a population, find measures of center and measures of variability, including range and interquartile range, make observations about the degree of visual overlap of two numerical distributions, and make inferences about two populations using measures of center and measures of variability. When I say measures of center, I'm talking about mean, median, mode. All right. And measures of variability, I'm talking about range, dealing with either the max and the minimum or the interquartile range, which is talking from the upper quartile to the lower quartile. So, the first thing that I want us to focus on, I want us to look at this student council survey results that we looked at last Friday, which was in block 2. So whenever we did this, we found a mean of 3.64 and we had a median of 3. So with that being said, what does the mean tell us about this data? What does the mean tell us about this data? Remember the multi-purpose track, they were trying to figure out how many hours on average people were going to use to track. So a mean is actually the average. So with that being said, the mean tells us what about this data?
The average.
Yeah, how many hours on average that the track is going to be used. So what does the median tell us about the data?
It's the middle of the data.
Correct. It is the middle. And in this case, the middle was 3. All right. So with this, what we're going to do is we're going to take some time to kind of take a look at this information. And we're going to try to talk about what the middle 50% of the data actually means. So if you would, Vincent, would you go ahead and read this for us, please?
The box plot uses whiskers to show the range of data from the greatest to lowest values. Another measure of variability is the interquartile
Good. The interquartile range.
range. It shows the difference between upper and lower quartiles.
Quartiles.
This range indicates the spread of the data. In other words, the interquartile range indicates how far apart the data are. If the box is narrow, 50% of the data fall close to one another. If the box is wide, the data are moved, spread out, or more spread out.
Good, good. So if we were to use this data and make a box plot, I'll do that now. You'll notice that this box is relatively what? Is it close or far apart? Is it
sort of far apart?
Okay, explain.
So like the front half, or like the first quartile is 1, and then the second quartile is 6.
Correct. All right. So that means that there's an interquartile range of how much?
5.
5. That's correct. And so what that means is that 50% of the data falls within 5 hours of each other. So the upper quartile range to the lower quartile range is 5 hours apart. All right. So with that being said, that interquartile range is dealing within 5 hours of each other. Now, Devin said that that's kind of far apart. So what would be closer? Like, give me an example of what would be closer if it was what?
Let's say like upper quartile was 4, it'd only be 3.
Okay, good. So if say the interquartile, if the box was wide, like even more than this, what would that mean about the data? What would happen to the interquartile range?
It would be larger.
Yeah, it'd be larger. So that'd be like the upper quartile at 10 or something, then that box would be really wide. And so that's telling you that your data is kind of spread out, okay? In this case, it's still fairly close. It's not super close, but it is 5 or less, so we'll call it close for this. Something that we should notice, though, is that the box is very close to the what?
The median?
Well, the median is dead center, which is right here. But what is our box close to?
The whisker?
It's close to the whisker, but what is this called? Who can help him out? What is that called? Starts with
the lower value?
It is the lower value, which is known as the
Minimum.
minimum. Good. So, with that being said, since it's that close to the minimum, basically what that's telling you is that, remember, this is 25%. The entire box here is 50%. So, what do you notice about this 75% of data?
It's the same size as the 25% data from the upper whisker, like the maximum whisker.
Okay. Did you notice anything else? When it says notice that the box is much closer to the smallest value than the largest, what do you think that means about the spread of the data? So 75% of this data is what? At how many hours or less?
6 hours or less?
Correct. And so if you have not answered question number 1 and number 2 in your workbook, this is the time to do it. So question number 1, what did it say, Alora, in your book? What did question number 1 ask?
I gotta go get my notebook.
Oh, that's never good. Who in here can tell us what number 1 said? Remember, we're on page 319 in our workbook. Go ahead, Hermione.
Notice that the box is much closer to the smallest value than the largest value. What do you think this means about the spread of the data?
All right, remember this is number 1. So we just said that this 75% is what? What does it represent?
6 hours or less?
Correct. And that's actually what this says. It says the box plot reveals that 75% of the data lies below the value of 6 hours, even though there is at least one value of 12 in the data. So we want to focus on this 75% is how many hours or less?
6 hours or less.
Correct. All right. So that would be our answer to what number?
Number 1.
Number 1.
One.
All right. Going to our next page in Agile Mind. If you would, Mr. Braden, would you read this, please, sir? With the new fresh earrings. Hooped out. Let's get it.
You call me.
Yep. The dude with the fresh hoops in his ears. Yes, sir. Go ahead.
Just read it, you said?
Yes, please, sir.
The student council members believe that their sample is a valid representation of the student population. However, they decided to conduct one more survey using a simple random sample to compare the shape of the samples and increase their confidence in the results. It is hard to generalize to an entire population unless you are comfortable that the results are typical.
All right. So this is what I want you to do for me. I want you to tell me what is the same. What's something that you noticed that's the same, Braden? What looks the same?
Well, they're both going 1 to 12.
Okay, so both of them have a maximum of 12. I'm going to stick with that right now. So they both have a max of 12. So these are the same. All right, good job, Braden. Kira, what do you notice that's the same?
I noticed that I forgot what it's called, but the part it says like underneath it says 1, 2, 3. That's the same.
Okay. So where it's
Like
labeled is
the
the
box
same?
under
Well,
the box above.
what about the actual box plot itself? So what parts of the box are the same?
All of them, or just one of them?
Just one.
I said the C 1, 2, 3 of the box above it.
I
That's
got
the
you. So
same
they're
on
the
both
same.
things.
Okay. Good. So like right here, what is this actually called?
The lower quartile.
The lower quartile is the same. All right. And then she said that this would also have to be the same as well, which is called the what?
The median.
The median, which is the what of our data?
The middle.
Good. What else do we see that is the same? Let's go with Satari. Do you see anything else that's the same?
The 0 point.
Correct, which is the
Minimum.
minimum or the smallest value. These are all the same. There's actually one more thing that's the same. Kind of gets left out a lot. The
whiskers.
The whisker. All right. So the whiskers are right here. Good deal. And the left whiskers are the same. What about the right whiskers? Are they the same?
No, one's longer than
Yep.
the other.
These are wrong. These are not the same. What else is not the same?
It's the upper quartile.
The upper quartiles are different. So do you think our interquartile range would be the same?
No, sir.
No, because this would be what?
5,
5. And what would the other one be?
4.
Correct. So let's see if we can answer question number 2 from this. Question number 2 states, how do the median, the interquartile range, and the range of the two data sets compare? So if we were to put that in a complete sentence, what could we do, Khalees?
You can say how far it is apart.
All right. What about, so if we do a complete sentence, what I want you to do is kind of restate the question. So how could we start that off?
The median, interquartile range, and the range of the two data sets compare because.
Okay. And so we said that the medians are the what? Are they the same or are they different? Help her out, class.
The what?
The medians,
The same.
they
they're
are
the
the
same.
same, correct. All right. What about the range? We didn't talk about the range earlier, but we said that the way that we get the range is to take the max and do what with the minimum?
Subtract it.
Correct. So what is the max minus the minimum?
12.
All right. So can we say that the ranges are the same?
Yes, sir.
All right. And we said that the interquartile ranges are,
Different.
and why are they different?
Because the upper quartile are in different spots.
Correct. All right. So if you would, Rachel, would you read this, please? This is what our answer should be for number 2 in our workbook.
The median and the range of the two sets is the same, while the interquartile range is slightly smaller in the second sample, 4 versus 5. This indicates the data are closer together in the second sample than the first.
Perfect. So, even though they are a little different, the two data sets are similar enough for the student council to conclude that their results about how much students would use the multipurpose track are valid. So they decide to present the results from the first sample to their principal so that they can get that multipurpose track. All right, on to question 3 in our workbook. What we're going to do is we're going to take a look at this animation and we're going to complete the same work in our workbook as what we're seeing here through page 9 slides. So if you would you read this for us, please, Devin?
You asked me to read?
Yes, sir.
The student council members want to create another representation to organize their data. Like the other representations, a histogram will help them investigate the variability in the data by looking at the mean. By the animation, to make a histogram from the student's council data, a tally chart helps you begin to organize the data. You will use the frequency table to sort the data into intervals.
All right. So most of you are going to see a histogram and think that's a bar graph. So most of you have seen a histogram. We've seen circle graphs. We've seen dot plots. We've seen tally charts. So with that being said, what we're going to do is we're going to take these and we're going to see how they compare to each other and which one that you like the best. Now, we are going to be creating a histogram in our workbook, and I believe that's on page 320 in your workbook. So if you do not have a workbook, what I want you to do is I want you to get a sheet of paper, and I want you to focus on our frequency and our interval range. And I want you to focus on creating a histogram with the same information that we're going to have, okay? So looking at this, what I want you to do right now, those of you that do not have your workbook, I want you to draw this right here because it's important. You're going to draw that on a sheet of paper and you're going to fill it out. Now, these students started this process by creating this dot plot from this information right here. So we're going to take that same information that's right here and we're going to use it to fill out our interval and frequency ranges. All right? So we're going to do that in our next step now. So if you look at this, if you would you please read this for us, Sophia?
To create a histogram, first insert line
Boundaries.
To sort the data into the intervals shown in the frequency table. Include the upper boundary and each interval with the higher interval. For example, include 2 in the second interval. To insert the
The line boundaries?
line boundaries, click on the space between numbers. To delete a line boundary, click on the line. Click complete table to check.
All right, so with that being said, so our interval of 0 to 2 would actually need to stop after what number? It would be from 0 all the way to what number?
2.
It would be all the way to 2. So we would stop it right there. All right, so we got 1. So where does our next boundary line need to go?
2 to 4.
All right, so would I put it after my last 3 or after my last 4?
After your last 3.
Correct. All right, where would my next one go, class?
4 to 6.
All right, so it's going to be after the last what, Vincent?
Wait, you said what? The
Where?
next one?
Yes.
It stops at 5.
Good.
6. 5.
Yeah, right between 5 and 6. Good. So where would the next one be?
6 to 8.
Correct. Where's that going to be at, Devin?
Right after the last 7.
Perfect. What's the next one going to be, class?
8 to 10.
Good. And then from 10 to
12.
perfect.
And then from 12 to 14. So after the 12.
Yeah, it won't let me do that though. But you are right. I don't know why it won't let me do that. So we got one that's stopping after 10. We got one that's stopping after 9, one after 7, one after 5, one after 3, and one after 1. All right. So with that being said, we're going to see if we can set up this frequency chart. So they're going to take our information and they're going to put it in the frequency. So how are they getting 13 and 11 and 6?
They're taking like all the numbers in between the line boundaries.
Correct. And so from 0 to 2, there's how many?
13.
How many from 2 to 4?
13.
How many from 4 to 6?
11.
6 to 8?
6.
8 to 10?
5.
10 to 12?
1.
And 12 to 14?
1.
All right. So what we're going to do is we're going to take our information from this interval and frequency table, which is right here, and we are going to draw our own histogram. So I need you to label your histogram on that page, just like this, and then just like this. So you're going from 0 to 14, from left to right and up and down. So x-axis, y-axis, that's the way I like to think about it. But we're going from 0 to 14 and 0 to 14. I want you to somewhat color or shade this in. So the first bar in this histogram is going to be from 0 to what?
2.
And how tall should it be?
13.
Correct. What would the next one be?
2 to 4, and it'd be 13 as well.
Correct. All right. Somebody other than Devin, what would the next one be? It comes after 3. Go ahead.
4 to 6, and it would be 11.
Correct. Why?
6 through 8.
Good. And 6 to 8 would be how tall?
6.
Correct. Tamarion, what about 8 to 10? Where would it be?
5.
Good. Vincent, what about 10 to 12? Help him out, Satari. How tall would it be?
1.
1. And Akira, what about 12 to 14? Help her out, Alora.
Can you repeat that? I was writing it down.
Yes. I was trying to see how tall our bar would be for 12 to 14. In our histogram, how tall would it be?
1.
Great job. All right. So we're going to take this and we're going to create hours right now. So I'm going to assume that's going to take you a couple seconds. So I want you to do that right now. So basically what you're doing is you are copying this or creating yours on a piece of paper.
So what do we write what number it is, or we just write like the base of it?
So you had to write these numbers in your table, and then you had to write down your label for 0 to 14 from left to right and 0 from 14 up and down. And then you have to draw each bar and shade them in.
Okay.
So I'm going to give you just a little while to do that. All right, my boys and girls. So looking at this, everybody should have created their histogram by now. If you hadn't, make sure that you're still knocking it out as quickly as possible. And we're going to see what it says here. It says the mean is a balance point for the data. The points on each side of the mean are the same distance, total distance away. So the student council members feel comfortable with the variability in the data they see in the histogram. So it says the points on each side of the mean are the same total distance away. All right, so let's see what they mean. So whenever they do that, what's happening? It wasn't really balanced out before, was it? So what's happening here?
They're balancing it.
Correct. So that means that half of the data is to the left of the mean and half of the data is to the
Right.
of the mean. So if you were to take 4 to 6, 6 to 8, 8 to 10, 10 to 12, and 12 to 14, and you added them all up, they would be exactly the same as the information from 0 to 2 and 2 to what?
4.
4. Is that making sense to everyone?
Yes, sir.
Perfect.
Sure.
So what does it mean to have a small or large spread in your data? If you have a small spread in our data, what's going to happen to our box?
It's going to get smaller.
Correct. If we have a large spread, what's going to happen to our box?
It's gonna get larger.
Correct. It's going to widen out, right? So why is it important to know the lower and upper quartiles? What do they allow us to find?
The interquartile range.
Correct. So is there an advantage of box plots over histograms or histograms over box plots?
No. I mean, they sort of give the same information.
Yeah, they give the same information. I think a box plot, when you know how to read them, you can actually get your information real quick. Like you can find your minimum, your maximum, your median, your lower quartile, your upper quartile. You can get all that really quick, but just looking at your graph, I feel like you're still able to see what you need to see as long as they have your mean listed. Because you're just normally, especially like for a survey like they were trying to do, they were really focused on getting that average or that mean so that they could tell their principal on average how much that track was going to be used so they could determine if they were going to get that track or not. All right, so today that's actually going to conclude our lesson, but what we have to do now is we're going to answer our more practice questions, pages 6 through 10. Now, these questions are going to be worth 2 points each. So every one you get right is 2 points. Every one that you miss, you're only getting 1 point. And if you do not do it at all, you get 0 points. So you have a possibility of getting an A, or you have a possibility of not doing really well. It just depends on what you choose to put in. What you put in is what you're going to get out, okay? So make sure that you're doing your best and you're working on this right now. While you're working on this, I'm going to be paying attention to what you're doing, okay? So For the remainder of our class, I want you to work on questions 6 through 10. If you have already worked through questions 6 through 10, then I want you to go to Upsmart Math and continue to work on Upsmart Math to build your skills